Welcome to another video on my Raspberry Pi 1 with Raspberry Pi Plus serial connection and RaspberryCam connected to a breadboard with a band cable and serially to a laptop. The Raspberry Pi is running Raspbian Linux, not the newest version, but that doesn't really matter. And as you can see, it is connected with probes to an oscilloscope, and it has been a while because of problems with the ADC. Last time, with last episode, it turned out that the electronics were fine, but the analog to digital converter, which is this chip, quit working and produced all but well, nothing but zeros. And after some lengthy tests, I could not do anything but conclude that the ADC, however unlikely, was no longer functioning. Unfortunately, a replacement was well, not doing anything either. So this is the second replacement, which I have to still install. I am using precautions by using an ESD set, electrical static discharge. So any statical electricity from me, which everybody has, is now kept away from the electronics, and that should be fine. Also, the power is disconnected, and when this chip is installed and the power is being reconnected, I should be able to get some nice results on screen. However, first I have to install the chip. I don't have to check the whole circuit because nothing has changed on the circuit. So here goes. And everything should fit in very nicely. I did some preparation by bending the contacts a bit, because they're coming quite wide and these are quite narrow, so it fits, I hope. And with this, I do hope that all my problems with the ADC are for now gone. One other thing that you may notice is that the NTCs are gone yet. So this is an NTC, and I have yet another NTC from fischertechnik, which is somewhere. But let's take this NTC first, which would be somewhere like here. No, this is not an NTC, this is an LDR. So that's something that I still have to do. Oh wait, yes, in the whole circuit there is an NTC. and that is what it was all about in the first place. If I get the package opened. And here's a nice light dependent resistor, and this is an NTC of course, and this goes right here. So now the circuit is again what it should be. And all that is left is now reconnecting and testing. So let's first reconnect the power. And well, testing is only running the program, which I can't show you on here. So here goes. Alright, update. As you can see, there's screen output, fischertechnik LDR right here, and the recording that I did earlier, screencast, went totally wrong. There was no audio at all. So, to tell what I've done is easier than to start over. I connected the ADC, analog to digital converter, I showed you. What I found next is that the thing doesn't work, but as I see now, I may have made an error, so it may be working now. I hope so. Sometimes things don't go exactly the way you intend, and it may be that these errors, these results, which are in here all 0, will prove to be working. So in the same package that this ADC is, was also the LDR. Now the fischertechnik LDR I took from another project, which will be there in later on again. What I also did was commenting out all these LDR channel 2, NTC channel and the resistor channel. They are not needed because the code in which they are used is commented out. So, with the present stuff, in the present situation, and that is also this situation. So, clock, mousy and CS bar, and that you can find here. So, clock, data, CS bar, and bar means inverted. And then this one mousy, which is no, this is not mousy, mousy. This is CEO, C0, not CEO. Anyway, with a correction made now to the LDR, let's see if it works. I would be very pleasantly surprised. Earlier on I did test the software pulse modulation on the LEDs, which works. So fingers crossed that this does work now. Well, you see the LEDs flash, but I don't see anything right here. So let me try this. No, there's not a glitch, not a blink here either. So I am going to reconnect the fischertechnik LDR. In a vain hope that this may change something, but it doesn't at all. Does this even give some value? Yes, it does, because when I change this a little bit with a screwdriver on this pot meter, maybe better light, then you will see this LED shine up a little. No, okay, I have to put it to the maximum stand, but it will do it. And now that I think of it, this is a bit too flexible, although it does work. I tested it before, so the connection is there. So where to go from here with every value still 0? Like I said, the wiring is alright, because I never changed it since it went wrong. Does this mean the end of the ADC series? I'm not sure yet. Not sure at all. Maybe I did something wrong, I don't know. But as yet, electronics works, because from the GPIO, where this is connection to, you see the LEDs blink. But the most important thing what this whole series is about, reading sensors, analog sensors, through an ADC to the Raspberry Pi. Still not functioning. Let me try one more thing. It shouldn't be any change. Let me check for another piece of wiring. Alright, let's do it again. Does this change anything at all? Nope, no value whatsoever. Another thing is, of course, there are some other things in here which I already showed you, and the weird thing is this part. It's all theoretical, but I still haven't been able to find how to address other channels than this one, or than this one. So how are the other channels being used? That's a very big question still. How to go on? Who knows? So far I have been concentrating on the LDRs to ports 1 and 2 out of possible 8. 0, 1 through 7 is 8. What I can do, futile or not, is testing this NTC, which is now only connected to a port that I can't address. So what I am going to do is put this one, which now connects 0 and 1, to here, so it will connect 2 and 1. Now alright, now it's connecting. Now the question is, what will it read? I will enable now LDR channel 2, because that is one which is now connected to the NTC, so it will be somehow confusing, or I can be less confusing and just use NTC channel variable, set it to 1. And have the NTC part of the software also set to that. Now I have to be careful with the code that I uncomment the right code. Alright, so that is done. And let's now off camera check for something. Let's see whatever happens. Holding the NTC, it is temperature sensitive, and maybe holding it with a body temperature of 37 degrees centigrade, Celsius, whatever, maybe works. But unfortunately everything stays stubbornly 0. So while I am very certain that my whole circuit is alright, and I did everything with anti-static discharge, so I can't have ruined the chip. That's all I can say. Where to go from here? The kit does have other interesting stuff, but the ADC, as it worked before, I don't know. I guess all I can do is check the wiring and see if I did something wrong after all. But for now it's over, unfortunately. And with that, yeah, shorter episode than usual. But where hardware fails, it's the end of the story. Even after 2 attempts, since this is the second replacement of the chip. For now, thank you for watching. If you like this video, no matter what happened, please subscribe to my channel. Like the video, give a comment, leave a comment. I appreciate it. Follow me on Twitter and Instagram. Like it, retweet, give a comment. Always appreciate it. And by the way, I answer back. Please donate to keep videos coming to you. You can also become a patron. Pledge some money per month and your name will be mentioned in some way, depending on your pledge. And this is going to be continued. Well, most likely. Don't know how. Maybe wiring, etc. Who knows? Bye bye.